So for today's notes, we're going to continue the common log. Before I do that, there's two problems here I want to review. Notice in both A and B, the variable is in the exponent. When we solve equations this way, we always look to get like bases. So notice in A, 9 to the x is equal to 3. We want to think factorization. We can break the 9 down into its factorization, which would be 3 squared. That is still raised to the x power. Power to a power then says to keep your base and multiply your exponents, which would give us 3 to the 2x. And then we have base 3 on each side. On the right, there's an understood exponent of 1. And once we have that, we can see that we have what's called the property of equality. Bases are the same. We can set the exponents equal to each other and then solve for x. So in this example, x would be 1/2. Similarly with B, both 16 and 32 can be broken down. 16 can break down to 2 to the 4th. 32 can break down to 2 to the 5th. We now have the power rule on each side, so we will need to multiply our exponents. Notice as I finish this up, we once again have like bases. So the property of equality says you can just set the exponents equal to each other. So we get 4x minus 12 equals 5x plus 25. I will subtract 4x. I will then subtract 25. And our answer will be x equals negative 37. No need to check either one of these answers because x is in the exponent position. This is not a log equation that we're looking for positive values for the base and the argument. Now take a look at the next two. If I ask you to do something similar for C, it says solve for x when the base is 5 to the x power is equal to 40. I don't know how to get 5 and 40 to be like bases. The left side is already factored. The right side, 40, can't be broken down to powers of 5. And so I'm not really sure how to do this problem. Similarly with D, if I say what does this equal and think back to our first day of logs, this is the common log. So I can convert to exponential form, which would be 10 to the x is equal to 37. Once again, x is in the exponent position, and I don't know how to get like bases for the 10 and 37. So we don't know how to solve these yet, and these will be calculator problems. So at this point, if you don't have your calculator, please take a moment to take that out. Notice I remind you of what the common log is, base 10. So it's not common to write the base of 10. We'll just write log of x. And you've got 3 examples here. I would like you to try each of these examples using your calculator. So you're going to look for the button that says log, and then you're going to type log of 1,000, or for some calculators it might need to be 1,000 log. And if it is a decimal, I'm going to ask you to round to 2 decimals. And here are the answers I get for that. So hopefully you're able to figure those out as well. And so now what are we going to use this for? Now that we have the calculator, we know how to put the information into the calculator, we're going to use this to be able to calculate problems and solve for x or evaluate when we can't get like bases. Again, x has to be in the exponent position. So if we can't get like bases when x is in the exponent position, what we're going to do is we're going to take the log of both sides. And I'll explain why that is going to be important. Notice my note there. We're going to leave everything in calculator ready form until the very last step. And then we're always going to round our answer to 2 decimal places. So you'll see, and I'll point out when I will actually take the calculator out. So take a look at number 4. Here's that same problem from above that I said we couldn't do. So I'm going to take the log of both sides, and you'll put the log in front of each of those because what's going to happen is those are going to become our arguments. Now look at that closely. If you were thinking work backwards, that is just the property of equality. That's a type 2 equation. We have log base 10 on each side, and we can drop the word log and get back to our original. But we're doing this on purpose because now we're going to use log properties backwards. Now that I have log base 5 to the x power, I can think power property backwards like we did when we expanded. which will enable me to bring the x out in front. So I will get x log 5 equals log 40. And then from there, you have x times log 5. And in order to undo our multiplication, we are going to just divide both sides by log of 5. And what I'm writing down right now is what is called calculator ready form. I have not touched the calculator and gone to any decimals until I get all the way down to where x is equal to something by itself. And so this is where I will now go to the calculator and give you a minute to try it. Once you go to the calculator, remember you're going to round to 2 decimals. And the big thing to keep in mind, just so that you are aware, this is not equivalent to log base 8 or log base 10 of 8. There is no such rule as just reducing the arguments. Log 8 would come from log 40 minus log 5. There is no division property for logs. Okay, our answer there should come out to be 2.29 if you calculated that correctly. Taking a look at number 5, I'll do the same thing. No way for me to get like basis. I have no idea how to break down 56.1 and 1260 to be the same. So I'm going to take the log of both sides. And that's going to enable me to work backwards and bring my power out in front as a coefficient. And now I'm going to solve that for x. The way I will solve that for x is dividing by the log first. Again, notice I haven't touched my calculator yet. And then I'm going to multiply both sides by 2. So this final line that I'm writing will be my calculator ready form. Now you can go ahead and pick up your calculator and see if you can get that answer rounded to 2 decimals. Okay, the answer for that should come out to be 3.55. Just one quick note before we go to the second page. I am choosing to take the common log of both sides because that is what my calculator can do. Some calculators can do other logs as well, but all calculators can do log base 10. So I'm taking log of both sides versus log base 2 of both sides or log base 8 of both sides. All right, moving on to number 6. One more where I just wanted to put a binomial in the exponent. I can't get 11 and 94 to be like bases, so I'm going to take the log of both sides. And what I'm going to do is just save a step and squeeze the word log right in front. This will enable me to bring that 3x minus 6 out in front. And since it is a binomial, I will write it in a parenthesis. And although you can distribute the log 11, since that's just a number, into the parentheses, I'm always going to recommend that you divide first. So just like I did on the previous 2, I am going to divide by log 11 as my first step. From there, to solve for x, we will add 6. And we will divide by 3. And what I just wrote here is my calculator ready form. It's at that point you can then go to your calculator, try and leave each thing in the calculator and round at the end. And if you're able to calculate that correctly, it should come out to be 2.63. Okay, if you are having any calculator issues, just make sure you make note of them, and that is something I will help you with next week. One final thing we'll look at today is going to be a nice little shortcut formula for some of the evaluating problems. So you remember if I look over at number 8, log of 37, yes, I can go right to the calculator because it is common log. However, if I look at number 7, I would not be able to go right to the calculator because it's log base 5. What I'm going to do is introduce the equals x and just show you again how I can do this by converting from log form to exponent form, and then I'll show you where the shortcut comes from. So on number 7, log on one side, I'll convert to exponential form. Notice the same problem from the front. I can't get like basis, so I'll take the log of both sides. to be able to bring the x out in front. And then to get x alone, I'll divide by log 5. And we already have the decimal answer on the front, so I won't do it again. Take a look at where that 40 and that 5 appear in the original question. I'll do the same thing for 7. Convert to exponential form, or 8 I should say. Can't get like basis, so I'm going to take the log of both sides, which will enable me to bring the x out in front to get x log 10 equals log 37. And then to get x alone, I will divide by log 10. Again, take a look at where you see the 37 and the 10 in the original problem. In number 7, the 40 is the argument, the 5 is the base. In number 8, 37 is the argument, the 10 is the base. So if you are evaluating, there is a nice shortcut that says you can just take the log of the argument divided by the log of the base. That would be written more generally as the following. If I'm asking you to evaluate log base b of x, and I want to know what that is equal to, it is going to be log of the argument, so log of x, divided by log of the base, which would be log of b. And just like I said earlier, I really could take log base anything. So if I really wanted to be technical, I would say that log base b of x is equal to log base a of x over log base a of b. It's still log of the argument over log of the base, but it could be that I'm taking log base 2 of both sides or log base 9 of both sides. So I'm going to stick with the common log for today, but it is possible to do it other ways. So our final two, I will use that shortcut to finish. In number 9, use the change of base formula. So I want to know what this is equal to. Because I have that logarithm, the change of base formula says I can write log of the argument over log of the base. So it's going to be log of 17 over log of 3, which if you do that in the calculator would be 2.58. And finally, number 10, we do have that 15 minus, so I'm going to just leave that alone for now. And then I see an evaluating log problem again. So log of the argument divided by log of the base. And then we would just go to the calculator to figure out what that is. Final answer would be 18.36. Do you need to know change of base formula? Not necessarily, because you can convert back to exponent form and then take the log of both sides. But it is definitely a nice little shortcut that you can use to make these problems a little bit quicker. Please make note of any questions that you have, and I'll be happy to go over them next week. Have a great weekend.